Good evening, everybody. I'm Suranga Javir. Uh, Here we are going to start lecture series of power system protection. Uh, I welcome you all. Uh, Before we start power system protection, we must understand what is a power system. What do you think? What is a power system? Power system is a system which is designed to generate electricity and distribute it up to customer end. It concerns of generation, transmission and distribution. Three parts. And all the equipments and all the lines, all the things related to that is called power system. So from generator into customer end, delivering system of power is a power system. So why we need protection against power system? Protection is one thing. If we need protection, we must have understand some problems of that system. There should be some problems. Protection is a solution. So for implementing solution, we should have some sort of problems. Let's briefly discuss about problems of a power system. Then you will have a better understand why we are discussing about power system protections. So one thing is power flow, second is equipment failure, third thing is fault. Fault is most dominant in sense of problems. Why the power flow is a problem? Power flow in early systems, if we talk about conventional systems, there were few generators, few customers and few lines. We exactly know where we are going to generate power. We exactly know where we are going to deliver that power. So the direction is predefined. It is unidirectional system in earlier days. But as the increasement of the demand, increasement of the customers, we have to increase the generation facilities. We cannot simply implement, or we can simply implement generators wherever we want. We can do that. We should concern about the availability of the energy source. For instance, if we need to install a hydro plant, we should have a good hydro source. We can't have good hydro plant in Ambattur area. We can. And the otherwise, we can't have very good solar power plant in hill country. You now understand what is the situation. Based on the availability of the energy source, the placement of the generators decides. So the placement of generators may be in all over the country. And the for instance, if we talk about Sri Lanka, we have hydro maximum season and thermal maximum season. We define it as based on the monsoons. In monsoon seasons, we have very much hydropower, so we generate most of the power based on the hydropower plants. But in dry season, we can do that, so we move into thermal plants. Okay, just let's have a look at the overview of transmission network of Sri Lanka. Here, this is Chunnagam, Northern. This is Puttala, Coal, Nimchilau, Kerawalapitiya, Karaniya, Sapugaskanda, those are you know where. And if we coming back here, Victoria, Randenigala, Upper Kotmale, Kotmale, Ukuele, then Vimala Surendra, those are there. Lakshapana, New Lakshapana, here we have Samana level. Here, hydro. Here, thermal. When we do not have much hydro source, we generate power from these plants and deliver it to hill country. When we have enough hydro, we generate power from these plants and generate to Jaffna and Puttalam and southern region nodes. Yes. The power flow direction we had to change based on the generation. Even in distribution network it happens. Why? In earlier days we were not connected generators to 30 kV network, but right now we are connecting. For instance, most of you have solar connections. It is generation which connected to low voltage network. We have mini hydropowers. In Sabaragama we have almost 200 megawatt capacity of mini hydro. 200 megawatts. Though all of them were connected to 30 kV network. So even in distribution network, the flow direction depends on the availability of energy source. And one of the other factors is in transmission network we know what will be the power flow, but in distribution network, because of the nature of the distributed generators, almost all of them are renewable energy, and the availability of energy source is non-predictable almost. So they generate whenever available the energy. So it is, we cannot predefine what will be the power flow. So it is very problematic system in distribution network. Right now I can't know what is the power flow in my network in that regard. And of course equipment failures are there. Equipment failure is a failure of equipment, not due to a fault. Okay. And the other thing is fault. Fault. What is a fault? The problem is, fault is an abnormal behavior of a power system. Then what is a normal behavior? Normally power system generators generate electricity in symmetrical manner and transmit and distribute to the customers. If you know the demand of the customer, say 50 megawatt, we need to generate only about 50. Agree? Yes. That is the nature of the power, normal. But if something abnormal happens, even though the demand is 50, generators may intend to generate 60 or 70 or something large. Or even though the demand is 50, generators are not generating 50. It is less and it collapses the system. That we call abnormal behavior. It is abnormal behavior. It's not normal. It is a fault. Okay, there are two types of faults, symmetrical and asymmetrical. Symmetrical fault, the fault is has no intention to disturb the symmetric of the system. What is symmetric? In generators, we generate electricity having three phases, having each phase have each same load. Okay, we transmit in the same manner, keeping symmetry, loads are same. And also in the fault also keep that same manner. Fault also create, keep in that symmetric manner. That means all three phases feeds the fault in symmetric manner. If one phase feeds 10 ampere to the fault, other two phases also contribute in the same amount. If if this is three phases, fault happens, all three phases short, and it may can get grounded or not. If three phases are shorter, then they will keep the symmetric manner. We call it line to line to line fault or line to line ground fault. It is symmetric fault. Okay. It is not going to change the symmetric manner of the network. The other things, asymmetrical fault. You can see in here, line to ground fault. It changes the symmetry. There are several reasons for line to ground. Line to ground fault. Two phases short and get it ground here, and two phases short and not grounded. It is also change the symmetry. All are faults. And the most importantly, you should know how to calculate the fault current. What is the fault current at this moment? Because these are not just theories. We have to apply it in our practical life. If you are going to be an engineer in a utility, or if you want to be a protection engineer, that means, now you may understand, you should know power system, theories of power systems before you learn about power system protections. So it is mandatory how to calculate faults. Here I am not going to discuss about calculation of faults, understanding of faults, natures of faults, the why the fault like that. Those things I am not going to discuss here, because it is a separate lecture. It is under power system and power system analysis lectures. But in my previous lecture series, I had to discuss within a day about calculation of these faults. Actually, what I did was how do some calculations of faults. We got practical approach how we actually calculate, and that is enough for design a protection scheme. So if you also need to know about calculation session, please let me know, because it is mandatory to continue this lecture series. Otherwise you may feel this dull if you do not know what is symmetrical fault and what is asymmetrical fault, what is asymmetrical network, how to convert asymmetrical network into three symmetrical network, how to do Laplace do calculation based on asymmetrical network, and what is lambda operator, those things. But I repeat, it comes under another lecture series, power system analysis. It is not power system protection. But if you do not if you know nothing about calculations of symmetrical and asymmetrical fault, yes, of course I can touch briefly. Okay, let me know, but not today. Let me know after the lecture. Just comments. I'll conduct a session for calculations of symmetrical and asymmetrical fault as I did in previous session. Okay, and those are the type of nature based on the symmetrical and asymmetrical fault. In power system, we define fault permanent and temporary faults. Though it is symmetric or asymmetric, whatever, we bother about permanent and temporary faults. 90% of our faults are temporary faults. That is the problem. What a temporary fault? Temporary fault means it's not going to sustain. It's not. It will not last long for many hours. It may only appear in the system for a few seconds or 1 minute, then it will vanish. Those called temporary faults. But those temporary faults may have cause permanent faults. We take an example about our previous thing. Let's think. If power line goes like this, if a tree fall into the line, fault current goes from the power line to the earth like that. As far as this tree is in the power line, this fault current continuously goes to the earth. This kind of situation we can call as a permanent fault. And in the same time, there may be a tree which very near to the power line. If some wind come, this tree may hit the power line and come back. Because of the wind direction, this tree may hit the power line and come back. It is a temporary fault. Just touch. Cause for this fault is, what do you think? Poor vegetation management. Because of the poor vegetation management, that sort of thing can happen. And also, if a bird, just imagine this is a bird, okay? If a bird goes to these two lines, it may spark power line, but it is not a permanent fault. It is temporary. And also, it can hit a lightning strike to the power line. It is also a temporary fault. Contamination of ionic particle can also cause faults. It may be temporary and permanent. You will study about contamination of ionic particle about solid breakdown, gas breakdown, all those things in your high voltage tech, yes, those are interrelated. Okay, so this is about faults, and I repeat, you should have a very good knowledge what are the type of fault, what are the causes for fault, what will happen if this fault occurs, how we monitor that fault, how we calculate that fault, uh, ranges of accuracies of calculations, those things you should have a very good understand if you want to be a protection engineer. If you want to be a protection engineer, so you have to have a very good understanding of those faults. So I repeat, if you want to do calculations, I'll, so let's go to protection. Again, in protection is always against faults. What we do is we isolate the fault using protection. What we do, we isolate the fault using protection. We cannot use protection so far to prevent the fault. So far we are not doing that. So far, maybe in future we are not going to monitor. Now it is going to happen a fault, also we should isolate this. That kind of nature is not in the power system so far. What we do is, after occurring the fault, we monitor the fault and we isolate the faulty sections. After occurring the fault, the protection works. It is not active, it is passive. There are so many researches and research for active protection, but still in research base, and it is very high cost. So in Sri Lanka we apply a passive protection. That means we let happen before and then we apply protection. And actually we are doing some researches for active protection schemes. I am also doing one. We'll discuss those research later. And now in protection, yes, it is isolating abnormal situation from the abnormal situation isolation. That means it already happens. Okay. In protection, there are two main categories: low voltage protection and medium and high voltage protection. In power system protection, we cover low voltage, medium and high voltage protection, but not the whole low voltage, because in power system protection we do not want to worry about the protection of a customer. That means inside a house, how they are going to survive against electrical fault, it is none of our question. In power system protection, it is not. But in power system, we should maintain our low voltage line protection and medium voltage line protection, medium voltage switchgear protection, transformer protection, high voltage line protection, transformer protection, switchgear protection, generator protection. Those things we have to concern. But for now you know what is a power system, what are the abnormal situations of a power system, why we need protection, what we are going to cover. We are going to cover low voltage, medium voltage and high voltage protection from customer end to generator end. There are so many protection schemes against so many faults. So we should have a good knowledge how to analyze a fault, and we should have a very good sense of applying solutions for particular faults. Okay, so far I think you are all clear. Now, as a completion, I'll do an overview of low voltage protection. This is just an overview for completion, and I know because I have worked so many years in consultancy field, and I am dealing with utility field. I have seen so many questions due to lack of knowledge of low voltage protection. I have seen so many questions, even in some very senior engineers do some very basic mistakes and do very poor designs because of lack of knowledge of the low voltage protection. So it is very important to know about low voltage protection. Just an overview. This is not the whole session of low voltage protection. This is an overview of low voltage protection, but one of the key things. Low voltage protection we do based on BS 7671 18th edition. BS 7671 is the standard, British standard, which covers all the low voltage protections. And in the low voltage sections, we have two faults mainly, earth fault and overcurrent fault. Those are the two faults. First, we discuss about earth fault protection, then we can discuss about overcurrent protection. Earth fault is if our phase conductor got earth, what will happen? What we are going to do against that fault? And overcurrent protection is if our conductor got delivering more current than it can bear, what we are going to do? Those protection is overcurrent protection. This is earth fault. One of the main concern of me is earth fault protection, teaching you in a low voltage section, because almost all the problems I have faced during my consultancy career because of the lack of knowledge of earth fault protection. If you know exactly what is earth fault, what is the protection, what is the solution, we can really solidly give a proper solution for several incidents. So let's think about this. Earth fault protection. First, before we choose a protection, we should choose earthing system. Before we go for protection, we should select earthing system. There are three main categories: TT, TN and IT. In TN there are three categories also. First, as the designer, we must select what I am going to use to my system. What will be my earthing system? I must select. And first, I have to say this also. There is a myth. Even very senior engineers have told, thinking about it. CEB only allows TT. It's a myth. No any restrictions have defined from Ceylon Electricity Board. You should be in TT section. You should apply TT earthing. There is no such a thing. If you are willing to have TN or IT or what systems, yes, you can. Please apply. But design is mandatory. Utility engineer may ask, what is your design? just show me the design with the qualified engineers say, chartered engineers say. It may ask because of the severity of the earth fault. But you are free to do. There are no restrictions. You are the one, if you are the designer, you are the one who select the system of earthing. It is free. Okay. So what is a TT system? Let's have a look. TT system. If this is my transformer, in the transformer we deliver 3 phase conductors and neutral conductor. And the transformer, the neutral is earth, source is earth, T. Source is earth. If I have my phone here, what I want is phase and neutral. Then what I do is I also get earth, not the neutral but the earth. For all the metallic part, body is earth. Load is earth. Here. My source end is earth, load end is earth, separately. We call it TT. Earth, earth. Okay. Then what is TN? In TN, this is my transformer. It may be earth or not, but it should be earth. Phase 1, phase 2, phase 3, neutral, and also I am giving earth. If I am the customer, I took earth, neutral and phase from my utility source. Here not earth, here earth. We call it TN system. And also we call it TNC system. Sorry, TNS system.